Welcome to Easy Math TV. We're going to start our discussion of quadratic relationships between two quantities. It's really not as hard as you think. Um, it's just one step up from linear. So we're just going to look at tabular information, and we're just going to see the number patterns right now in those in the table. So that's basically where we're at. Um, Set up your spreadsheet the way I have it here, with column A is going to be our delta X, column B is going to be our X values, which happens to be our quantity sold. Column C is Y, which is our price. Column D is delta Y. Column E is capital R for revenue. Column F is going to be our change in revenue, so delta R. And then we have a new column G that is going to be delta R, so change in revenue. Exactly what you think it might be. So go ahead and set up your spreadsheet and put in your X's. Your X's should go from 25 all the way down to 80, like you see here, 25, 30, 35, 40, all the way down to 80. And the Y values should start at 30 and go all the way down to 8 in a pattern that you see here. So 30, then 28, then 26. So see if you can get those typed in. And I want to see how much of this table you can actually fill in on your own without my help. So see if you can get your delta X's and your delta Y's. And revenue, capital R revenue, is equal to price times quantity sold. So see if you can work that out. It's price times quantity sold. So see if you can figure that out on your own, what to put in column E. And then column F is the delta R. And then column G is a little tougher. You may not get that the first time around. That's okay, but I will be explaining it. So pause the video and go back and go and see how much of this you can fill in, and then come back. So now that you're back, we're going to this is the big reveal. The big reveal of all these numbers. So as you can see, our delta X's are in fact constant. They are 5, 5, 5 all the way down. So basically that was numbers in column B that are subtracted. So B4 minus B3 was the first one. And then in our delta Y column, we have negative 2's all the way down, because delta Y was equal to C4 minus C3 was the first one, and we actually get a negative number. So this is what happens with demand, by the way, when price is based on demand. The quantity sold is going to, as the quantity sold goes up, the price is coming down. So our delta Y's are negative 2. Our revenues, then, you can see them over here. They start at 750. And just so you can see that formula, that was equal to, the first one was in row 3, and it's equals B3 times C3. That's our price times quantity sold. So that had nothing to do with the delta X's and the delta Y's. I just have those there for comparison's sake. So when you fill the formula down, you should see a pattern like this. And in the text box, I've actually pointed out like what is really interesting here. So what is really interesting is that we can see a symmetric pattern of numbers. We call that apex there the fulcrum of that symmetry. But that's not a mathematical term. The word fulcrum is from physics. But in math, we call that the vertex, or the turning point of the quadratic pattern. So the turning point in this case occurs when revenue is 1,000. And then on both sides of that, the revenue is decreasing. It started at 750, went up to 840, went up to 910, 960, 990. And then it got to 1,000, and now it's coming back down again on the other side. But those numbers are reflecting each other. They're kind of mirroring each other. So that's our first indication that we actually have a quadratic relationship. if I move this thing over a little, um, you can see that our delta r's are not constant. Um, the first delta r is equal E4 minus E3. And when you hit enter on that, we get 90. And then when you copy that formula down, you can see that the delta r's are changing. But when we go to the next column, in column G, when I calculate the change in our delta R column, so equals F5 minus F4, for example, in G5, so that's our first value that we have is in row 5. Hit enter and fill down. All of a sudden, you see that's constant. So when the delta R is constant, we actually have a quadratic relationship. Isn't that interesting? So we're going to continue our discussion of quadratic functions throughout this playlist. Like, subscribe, comment down below, share this video with anybody that you think might find it helpful. See you soon.